Hello everyone, I'm Rodney Osodo from Abstract Machines and we are building Propeller, our Wasm orchestrator built on top of our SuperMQ. So why are we building Propeller? This is because we will offer unified management across environments. So this is on cloud and also on edge devices. We are leveraging on Wasm near instant start time for efficiency. We support function as a service. We are OCI compliant, meaning you can be able to pull workloads from an OCI registry and deploy them on the Proplets. And we utilize SuperMQ for secure and efficient communication. So what are some of the components of Propeller? Propeller has a manager. This is a central task orchestrator, which has an API endpoint. Then the Proplets are the worker nodes that execute Wasm tasks. So the Proplets can have Wasm runtime inside it, called Was0, or they can use the host Wasm runtime, for example, Wasm time. We also have a proxy. This is for distributing Wasm images from OCI registry to Proplets using MQTT. At the core, we are using SuperMQ, which is an event-driven infrastructure for service communication. So this is generally our architecture. We have a Proplet, and we have two types of Proplets. So we have a cloud in cluster or cloud Proplet. This is for deploying and managing Wasm workloads on native within the cluster. Then you also have an external Proplet or edge device. So this is just a remote non-K8 Proplet that is running somewhere different. So they talk using SuperMQ, using MQTT via SuperMQ. Then we have the OCI registry, which the proxy helps to fetch modules from the OCI registry, then send it to SuperMQ via MQTT. Our manager is a Kubernetes operator that manages deployment of tasks and Proplets. So the user interfaces with it using the Kubernetes command line tool. So what are some of the use cases and benefits of Propeller? We have an IoT edge workload, so you can be able to deploy AI inferencing or data processing workloads onto constrained devices. We are cloud native. We can seamlessly extend cloud microservices to run closer to end users and data sources. Also, we can be able to run on embedded systems, and we use Zephyr together with Warmer as the internal Wasm runtime. So let's have a look at the demo. So this is the custom resource definition of a Proplet. We have this is the Proplet, then this is our version. Then we are specifying the namespace and also the connection config. So these are needed for communicating via MQTT to the manager. Then we also have the K8. Since this is a K8 Proplet, we define the image name, log label, and replicas, and also we request the following resources for CPU and memory. So how to deploy this is just K8 apply this Proplet, and this will be deployed to your K8 cluster. For an external Proplet is almost the same, but what changes is the MQTT address, of course, and also you can also change, you can specify the capabilities and also the device type. So this is useful when deploying the task. We also have another thing called the proxy. So what a proxy does, it converts the OCI image to Wasm module, then send it to the Proplet so that it can be able to run. So we just this is a normal deployment file. We specify the image and resources and deploy it to the cluster. We'll go to the task. So this is a simple task definition. How we deploy it to a specific namespace. And so this is just an addition example that it has been base 64 encoded. So this is the function itself, and the inputs are 10 and 32. So we can also specify the resources for this. Currently we don't want, and also we can manually specify the Proplet, but currently we don't want. So I'll just deploy this. So what I'll just do, I'll copy this path. I'll copy this, then I will deploy it. So how to deploy is it's apply, just do task. Once it has been deployed, we can check its status by doing k8. We need to specify the namespace. Then we specify, we want to describe this task and the task name itself. So once we do a describe, you can see that it has already been completed. And this is the function name, the inputs, and these are the status, and the phase, the last phase, and this is currently the current phase, and these are the results. The next thing we'll try and do is we'll try and have a look at the one with an image. So instead of the function, we just provide the image URL, and this will pull it, proxy will pull it, send it to the Proplet, and it will be able to run. So I'll just copy that path. Do a describe of this image, and what happens is we can see the results have been finished and the task has already been completed. This is 10 plus 89, it gives you 99, but this was using the image URL. The dashboard, so which will be brought after you've started Propeller UI. So one of the key factors to check is on channels. We only have one channel called manager. So in this channel, you can have a look at the topology visualization. So this is a proxy, this is an external proplet, and these are case proplets. So these are proplets that were defined on the system. So we can have a look at those proplets. So we have a proxy, manager, external proplet, and K8 proplet. So we'll have a look at the K8 proplet just to see some of the modifications. So you can have a look at the logs page. So these are all the logs that for this proplet, and these are also searchable. So I can just do like this, or I can search by log level. I can also clear and also refresh the logs. The next thing is the manifest. So this is the K8 manifest. This is the proplet status, the image, log level and replica, resource specification, connection configuration, and also just the status conditioning of the proplet. We'll go to the jobs page. So we have two jobs. We'll have a look at both of them. So this was just the base64 encode example. So this is 10 plus 32, it gives you 42. And we can also see execution timeline and execution summary. We'll have a look at the other job. So this is for the image URL. You can also see the image URL and the inputs and outputs. And the task status is completed. So this is also the executional summary. It took around 6 seconds because of pulling and running the example. Yes. What's next for Propeller? We aim to have a multi-manager support. This is implementing a highly available decentralized manager. So not only have a K8 operate manager, but also an external manager. We aim to have an advanced scheduling mechanism. So this is for specific for Wasm unique workloads. We also aim to extend our Wasm features by integrating some of the features such as the component model for better interoperability. We also we aim to expand our documentation, provide more samples and tooling to grow the Propeller ecosystem. Thank you, everyone.